What is up, everybody? So this is our second video for 6.6 covering kites. Let's get right into it. So this is our last shape for quadrilaterals that we are covering. So a kite looks like a traditional kite shape. So that's where it gets its name. I think we've all tried to fly a shaped kite like this. But as kites progress, right, they become like dragons and eagles and stuff like that. So the kite's going to have a lot of properties, but the homework's only going to really deal with the angles. The practice quiz will deal with a couple different other aspects. So let's get right into it. So kite has four sides, all right? And the first thing to know about a kite is that it has two pairs of congruent sides, and they are consecutive, or they share a vertex. So as you can see, right, you have side AD and AB that share A. Those two sides are going to be the same length. And you have side DC and BC that share point C. Those are going to be the same length. So AB is congruent to AD, and BC is congruent to DC. So every kite will have two pairs of congruent sides. They are not opposite, they are now consecutive. So that's the difference between a kite and the parallelograms that we've looked at. It has one pair of opposite congruent angles, okay? And those pairs of angles are the ones that are going to be usually the largest, or the obtuse angles within your kite. Okay, so one pair of opposite congruent angles. The diagonals are perpendicular, so the diagonals are going to form a right angle. Okay. The opposite angles that are not congruent are bisected by the diagonal. So angle A and angle C, those are not congruent. However, diagonal AC bisects those two angles. Okay. And then the shortest diagonal is bisected by the longest diagonal. Okay, so the short diagonal is bisected by the long diagonal. Okay, but the short diagonal does not bisect the long diagonal. All right. And so those are the five characteristics. Sorry guys, I had to step away for a second. But so there's five characteristics: two pairs of congruent sides, one pair of opposite congruent angles, diagonals are perpendicular, opposite angles that are not congruent are bisected by the diagonal, and the short diagonal is bisected by the long diagonal. Now, one thing that's not part of a characteristic that's important to point out is that the two smaller triangles, when you draw diagonals, are congruent. So triangle 1 is congruent to triangle 2. And the two larger triangles are congruent. So triangle 3 is congruent to triangle 4. Okay? So let's look at a basic problem like this. So look at the markings, right, where we know that this side is congruent to this side, and this side is congruent to this side. So if I wanted to find the missing angle measures, the angles where the two different side lengths are meeting are always going to be your opposite congruent. So I know that one's 110. Now remember, this is a quadrilateral, so that means all four angles have to add to 360. Common mistake I see is people put 40 down here thinking that these are congruent, okay? But that is not true, okay? So the way that we would solve for that is I would just do 360 minus 110 minus 110 minus 40, and that gets me to how much that fourth angle is. In this case, it's 100 degrees because all four angles have to add up to 360. Let's look at this problem here. Okay, so now they're just giving us some lengths. So I know that that's 10, which means this would be 10, and this would be 14. So if I wanted to find all the missing lengths here, remember, you know that these are the same because that short angle is bisected by the long one. So what we can do here to solve for x is I could use Pythagorean theorem. X squared plus 8 squared equals 10 squared. X squared plus 64 equals 100. X squared equals 36. So x equals 6. Once I know that length, I can now solve for y using Pythagorean theorem one more time. Y squared plus 6 squared equals 14 squared. Y squared plus 36 equals 196. 196 minus 36 is 160. Taking the square root of 160 is 12.6. So y would equal 12.6. Notice I can find a lot of information if I'm just given very little, which is kind of a theme with all of the shapes that we've been working with. So now here, if I'm trying to find missing angle measures, I know that angle is 26, and again, just to point out, that means this angle would also be 26. The long diagonal is an angle bisector. I know this is a right angle, so angle 2 would equal 90. To solve for my angle 1, I would do 180 minus 90 minus 26. That gets us 64 because we have our right triangle right here. And then if angle 1 is 64, then angle 3 has to also be 64 because these two triangles are congruent. Okay? Now, as you look at today's homework, it's important to notice that it's pretty much all dealing with angles. The practice quiz that we're going to do later on will have some questions that deal with the side lengths. But the side lengths, to be honest, is going to always be Pythagorean theorem stuff, as to where there's more variations of the types of problems if you're only dealing with the angles. So I'm going to make sure to go over this with you tomorrow after you've watched this video and taken some time to do the problems. Please let me know if you have any questions.